Good afternoon, everybody. Welcome along. This is our first online energy efficient building seminar. My name is Andrew Butler. I'm the technical manager with Core Insulation, and I'm very excited to be the host of the first session in our webinar series. Firstly, I'd like to introduce our brand new EEBS event. The ideas and the key themes behind this year is empowering you for nZEB. So this EEBS event is part of a collaboration between some of the most knowledgeable experts in the low energy building industry. We've practitioners, educators, and communicators. Partel, in partnership with Core Insulation, Daikin, Nordan, and Harmony Timber Solutions, were responding proactively to the recent changes in the building regulations. And in the coming 3 weeks, we will provide an integrated approach to sustainable building design and construction in accordance with the nZEB requirements. The CPD webinar series will present a range of envelope and building performance solutions that aim to help you meet the nZEB standards for both new build and retrofit projects. You're invited to join us each week for this. I'd like to take the opportunity to thank our media partner, Passive House Plus magazine, for their kind support. Great publication and always full of some really good information. The first CPD webinar is presented today by Hugh Whiriskey. Hugh is the technical director and founder at Partel. Hugh will be talking about high performance air and wind tightness, thermal bridging solutions also. Hugh is a certified passive house designer and a specialist in sustainable building, energy efficiency, and has extensive knowledge in the design and construction management, building fabrics, and heat recovery ventilation. Hugh has particular experience in low energy construction. With over 20 years of experience in the industry, he has been involved in many different projects, ranging in scale and complexity from large commercial developments, large residential developments to bespoke residential dwellings. So I'm going to hand over to Hugh, and then towards the end, we'll have a question and answer period as well. So if you have any questions, pop them in the Q&A as we go along, and they can be covered towards the end.
Thanks, Andrew.
I'll just give you the control here shortly there, Hugh.
Cheers.
Just have to find you. Yeah, let me see, go back to this one. And there we go. All yours, Hugh.
Thanks, Andrew. Okay, so I'm going to share shortly, everyone. You should see the presentation in the next couple of seconds.
Yeah, see that there, Hugh. Thank you.
All good. Great. Okay. So thanks everyone for joining. Appreciate you taking the time, and thanks Andrew for the intro. Kind of as Andrew has said, we'll take questions at the end, so you can pop them in the chat or hold them till the end of the presentation. The target with this presentation is to give you an overview on the best practices for air and wind tight sealing. We'll be getting into some building physics. We want to be sure you can get some technical information from that, and all the way through to membranes, adhesives, testing, and some case studies. As Andrew mentioned, I'm the technical director. I'm a founder at Partel, but I'm quite actively involved in what we do in everything from a product development through to the building physics side of things. We are an Irish company, but we're established in North America, the UK, Ireland, and some European countries. We're founded by myself, an engineer, but also an architect. So we've always found that kind of, I guess, that relationship with specifiers and people on construction sites has been good as a result. But really, kind of in 2011, we went quite deeply down the passive house route and found that our interest was really in building physics and products, and yeah, led us down quite an interesting path where we found we've been able to come up with some really bespoke and tailored solutions for our market. And that was always the key, is to be, I suppose, more relevant and more appropriate for the markets we're active in. So the subject today on nZEB, so the nearly zero energy building standard. What does it mean, and kind of what are we dealing with? So the law at the start is worth kind of considering, or the directive, essentially that a nearly zero energy building has a very high performance index. It's also that the nearly zero or low amount of energy required for the building should be covered to a significant extent from renewable sources, and also that the approach should be selected based on optimizing long-term costs and maximizing return on investment. The results of that relative to this area are changes, are pretty significant changes from 2019. So it applies to all buildings commencing construction from the 1st of November 2019. There is a transition period which you could say has now expired. So really it applies to all residential buildings from now. The big changes are BER now is essentially or equivalent to an A2. The MEPC, the energy performance coefficient, has been reduced to 0.3 or below, and the carbon performance coefficient reduced to 0.35. What that kind of means is that the primary energy used must be less than 30% of a 2005 reference house. And for the CPC, it's that the CO2 emissions must be less than 35% of the 2005 standard. It's still quite a big jump from our last regulations, in the region of 30% reduction in both of those figures. And that definitely makes us focus more on the types of technology we use in buildings. So from our low efficiency or high efficiency, low power consumption heat recovery systems, or DCV, but also the thermal bridging, airtightness, and the insulation. So looking at the airtightness, that has been reduced to a requirement to 5 meters cubed per hour per meter squared. So that is the new standard that we have to achieve. But I guess kind of interestingly, what's happening, and Passive House Plus would have covered this, prior to the implementation of nZEB, the standard in Ireland was about 2.9, and we're starting to see the nZEB houses come through, and they're down to about 2.5. So kind of what's maybe relevant with that is that designing to achieve airtightness of 3 exactly is quite hard. So we think people are starting to focus on getting below 3 and staying consistently below that. But there is also something to be aware of, that when our air permeability is below 3 air changes, we then need to use a mechanical ventilation system. It's a requirement. If we are between 3 and 5, technically we're still compliant with Partel, but we then need to use natural ventilation, and that's quite onerous. And it's been dubbed the Swiss cheese house, lots of things like that. So not a very efficient way of doing it. So we are seeing people focus on, really getting down to 2.5, and it's a trend that we expect to continue to reduce. There is also a change in how the renewable energy contribution is accounted for. It's based on the energy demand, so it's not a fixed figure like it used to be. So why do we build airtight? But before we get into kind of the building physics of it, it's important to, I guess, know that it applies to all buildings. So all residential, all commercial, it should really be to all types. It's a systems-based approach, so always a full internal or a full external system. So main points for why we build an airtight home: to lower energy costs. It's the kind of easy one, the one that everyone is on board with, and it helps with our running costs. But that's really only a part of it. To improve comfort levels is quite relevant. If we take a house, let's say 2 houses side by side, one built to quite a good level of airtightness, let's say Passive House standard, and another where they've achieved maybe 3 or 4 or 5. The end result of the occupants in that house is that they will feel the need to heat the house to a higher level for the ones that aren't airtight, whereas you'll feel comfortable at a much lower temperature in the, let's say, passive house or a house with an appropriate level of airtightness. So that kind of means, 1 and 2 feed each other. If the airtightness is good, we're going to use less heat to heat it, but we'll also be heating it to a lower temperature. Indoor air quality is particularly relevant these days. It's really I think it's the last 12 months was the time when everyone, I guess, finally started to acknowledge that, we're spending more of our time indoors and the air quality inside is really important. And lots of that awareness is down to COVID and how the virus transfers, but it's always been relevant for airtightness. So we're looking at our products as an air and vapor control layer, but they will prevent harmful VOCs from entering the building through the building fabric, but also to help control PM 2.5 and 10. Structural integrity is an important one for me as an engineer, and it's a huge factor. If we can get our airtightness right, it means that we can have really extend, the longevity of the building. So it's an air and vapor control layer. Our typical house is generating about 10 to 15 liters of water vapor per day. So if we happen to have our layering incorrect or aren't using the right system from inside to outside, we can be allowing moisture to build in the fabric. This little slide, the kind of principle with it is to, I suppose, show what a construction in a timber frame would be like without a vapor control layer. So we have a vented cavity, a breather membrane, OSB, insulation, and plasterboard. We've got temperature inside of about 20 degrees and 60% relative humidity. And on the outside, it's cold. So kind of something everyone will get is this is probably our dew point. And what's actually happening in this type of a wall is warm, humid air is being allowed to cool, where it loses the ability to hold water vapor and essentially reaches a dew point at about 13 degrees, and we get condensation and actual, some cases, liquid water building up. So that's going to shorten the building lifespan. So the introduction of an air and vapor control layer here can stop that happening. In terms of how airtight we should end up and is something too airtight, it doesn't really make sense, because a ½ meter cut, so a half of that stud, just a little cut with a Stanley knife, can allow the equivalent of a coffee cup's worth of water vapor per day into the construction. So that can be enough to overload it. So it's definitely worthwhile to specify and look for very low levels of airtightness. I'd like to show this slide. It's I suppose, an effort to explain one of the most misunderstood words in the industry. So breathability, it's often associated with air, but in the context of building performance, it's about water vapor. There is a way to kind of compare different products, and all airtight membranes will have something called an ST value. An ST value is the equivalent thickness of air. So it's how long does water vapor take to pass through air. So just to give a visual on that, this is an outside membrane, like a roof membrane. We're looking at an airtight membrane here. Something that's a vapor barrier moves up to STs of 100 meters, vapor tight 1500 meters. And kind of what we're looking for here is something that's getting more breathable as it goes from inside to outside. And that's kind of what can control the buildup of water vapor in the construction. One of the main products for this in the UK and Ireland at the moment is Isoperm Plus. It's a Partel product. It took about 2 years to become what it is, a pretty long development process, but we've got incredible results with it. So it's one of the best performing products on the Passive House component database, but really it's tailored to work very well with our tapes and our adhesives. There is a bit more to be aware of in terms of active moisture management. So there is a range of systems that we are producing called the VARA system. It's I suppose a more active or a smart membrane. And just to give an overview on how it kind of works and what it does. So it's designed to be a sustainable key building component. It can be used in all types of insulation. it's moisture variable, so the smart characteristics mean those SD values we spoke about can vary relative to the conditions. So it works like an adaptive or like a human skin. It can regulate between interior and exterior. It can also help to control the relative humidity of the building. And finally, the thermal performance is enhanced. So any U value calculation that we do assumes perfect air tightness. So really just by the inclusion of that, we're sure that we can achieve the designed U values. So we're going to go a little bit deeper on the VARA layers. So what it does and what it can offer our building, it can facilitate additional drying in the summertime. So it'll allow that stud to dry to the inside. In wintertime, the membrane installed here will become more tight and will start to protect the construction from vapor entering it. These types of products are absolutely needed when the outer layer is closed or vapor tight, or on the ceiling or roof. That could be in a flat roof, but it can be used kind of in any situation. It's a short video on how the product works. It has a complicated kind of 4-layer structure, and where the middle layer of the product expands in winter, and that's actually what helps close these pores that are open in the summertime. So when we look at what this means and how it actually impacts on our building, this is a slide taken from WUFI, and I'm going to explain a little bit more about WUFI, but really what we're looking at here is a high altitude pitched roof, vapor tight externally. So we're only able to dry to the inside, but the comparison is what is the moisture content like in the roof overall using VARA Plus, OSB, a standard variable, fixed perm or PE. And kind of the results from it are quite impressive. We're showing that VARA Plus is allowing it to dry, and that's giving it that kind of safety, whereas all other products are either increasing or remaining constant at too high of a moisture content. You can use the VARA layer based on the sheet applied or membranes. It can be through a fluid applied project or fluid applied layer. We'll look at that in a minute, but also with the tapes and membranes. So for us, that's the overlap tapes, window tapes, and a new product called VARASEAL X, which has adhesive on both sides. So it can actually be pre-attached to windows before you insert them into the fabric. This is an example of the complete VARA system. So all tapes, membranes, complete variable technology. And we'll look a little bit about the fluid applied project. So it comes in 2 forms. There's a brush applied, which is used to seal joints and connections, and a roller or spray applied product. You'll see in this video both products being applied. So the spray applied product is used in 2 layers. First layer is generally a little bit thinner, and that's what you'll see in the video here, but you'll also see the brush applied being used to seal a floor to wall connection. So it's a really interesting type of product and a big development in the area of airtightness. It's amazing for large areas if we need to cover a lot of airtightness in one day, but it's equally a kind of a development on the labor charges for complex buildings. This brush applied product, I guess, is kind of hard to apply incorrectly, which can be a useful characteristic. So when we look at WUFI condensation risk assessment, look, some of you mightn't be aware of it, but it's an important piece of technology. It's a dynamic modeling tool, and what it does differently, I guess, to what you might get as a standard condensation risk assessment is it takes account for rain, construction moisture, airtightness, vented cavities, and the fact that some materials are hygroscopic. So really it's taking a full and true picture of what the construction is like. it's a requirement to use it in all flat roofs. So that's in our building regs. We should be using it for all flat roof constructions, and we should be using it for all solid wall construction. It's also worthwhile, you know, if you have any doubts or you want to be sure how you're building on repeat, to just reach out and ask us, you know, can I get a WUFI condensation risk on this typical build-up? And this is kind of what it looks like when we take a section from an architect. So in this case, we're provided with a timber frame build-up with a brick on the outside, a vented cavity, OSB layer, and insulation in between. So we then build a model based on that. And kind of from what we were talking about at the start, where we mentioned the ST values and construction getting more vapor open from inside to outside, there's a little bit of a red flag with this build-up because it's got OSB here and here, and already know that it's not going to be drying maybe as quickly as we would want at this point. So when we take the assessment in WUFI, we're actually building in the airtightness. So I think we assumed 3 air changes in this one, and we can also decide how breathable the surface cavity is. So the outer layer of OSB, the one at risk, has a maximum moisture content of about 16.5%. It is drying down to about 10% in summer, but really that's a little bit higher than we would like. It doesn't give us enough room for any buffer, and it's, you know, really in the borderline area for safety. So when we get something like that, we're definitely making a recommendation. It can be a small change, but it can make a big difference in the building longevity and safety overall. This is the layer in the middle, the insulation. It's you know, it's comfortable. There's no issues at all. It's about 10%, and the OSB on the inside, absolutely no issues, about 8%. This slide shows the OSB that we had at the start up at the 16%, and if we change this to something more vapor open, we can reduce down to, you know, approximately maximum of 12%. So a huge kind of safety factor now built in should construction not go exactly as planned. So how do we build airtight? It's a 3-step process. So there's an onus on the architect or the engineer or the specifier to give us an appropriate design and really to try keep it simple and attainable on site. That's often possible, I would say, and we'll go through some of the details that we can provide to help with that. But after that, we've got the QA on site. That requires a buy-in from the contractor on site, from the main contractor, and they really need to bring along their trades. So everyone needs to be part of the process to achieve a good result. On the testing side of things, we're looking at 2-part testing giving us the best results. So if we can test when the membrane is at this stage, it means we can actually impact on the final results. So if there's an issue or and it's very much part of the process. The best airtight installers absolutely rely on the blower door test at this point. So on the details, when we sit down with an architectural firm, if they're looking to make improvements to the airtightness, it's to decide kind of what each layer is, what it's doing, and also what the connections are like. So the red line principle is, so there's a couple of people with mics probably left on. If you could switch them off kind of until the end of the presentation, it would be great. There's a little bit of background noise. But just to go on to that, so we're looking at probably in this type of construction, a concrete floor being the airtight layer, and these connection details, that's kind of where the detail is, and that's where we need to make improvements. We supply a pretty deep kind of range of already worked through in WUFI solutions. So the correct membrane on the inside, on the outside. It's for timber frame, for masonry, pretty much all types of construction, even the retrofit are available. You'll get a copy of those after the presentation. This is showing how to make a suspended floor airtight in a retrofit, and something like you know, easy ways to make service penetrations tight. So when we get to site, This is what it should look like post-application of membranes. If the membrane application looks like this, so the membranes are tight, there's no big creases, it looks quite neat, the likelihood is you're going to be getting good results. You still need the blower door test, of course, but that is kind of how it should look like. So we are still seeing, unfortunately, things like this on site. So this is what used to be considered a vapor control layer. It's the cheapest piece of plastic you can buy, and in this particular site wasn't overlapped. In this case, cables were just pulled through it as much as you want, and when it did fail the blower door test eventually, with figures of 13, spray foam was used to try and make good to it. Another example of kind of problematic connections, so floor areas like this, doors, there needs to be a clear plan on how the door is going to be made airtight. So again, this case, it's lots of spray foam and polymer, tape stuck to windows and doors, and this was all when we were able to see the site to try and make it airtight late. Here we're looking at a steel where people have kind of half taped over some of the bolts, but also just not airtight. Same cheap plastic used here, again not airtight, and this is the effort at the remedial work. So you know, just appalling kind of details. And generally if pipes are too close together like that, you still have a lagging on the pipe. There's no way to make them airtight, so it needs to be considered and planned. And this is really what pipe connections should look like. There's a wide range of these cab seal grommets available for pretty much all types and sizes. So everything from the electrical conduit right up to a 200 ml pipe, you can buy a perfectly sized and preformed sleeve, and yeah, absolutely no issues with your airtightness. If the shapes you're dealing with are variable, you can use some tapes, some of the flexible tapes from our range, like Conlex. They're really quick and easy to use, and yeah, just require a little bit of planning. It's important to have them on site so that people are kind of willing to use them. If they don't have them right there and then, they might be tempted to kind of do something else, and that's where we get the problems. So again, kind of afterthought, lots of spray foam, and you know, ill thought out kind of, or maybe subcontractors not on board with airtightness. This slide shows a nice example of kind of what not to do with conduits. If we ever push our heat recovery ducts too close together, so here, this joint is unsealable. There's no way to get it perfectly airtight. It's the same issue here. We can't get around it. It's too tight into the corner, so it doesn't facilitate airtightness. And again, you'll see people using lots of spray foam, trying to patch or make good, but it's gone too far if it's like that. So back to the airtight test. So we know from building regs, we're looking for air changes of 5, passive house is 0.6. You know, ideal world, we'd like to see everyone achieving below 1. It's definitely an okay standard to go for. So onto wind tightness. It's a, you know, an equally important area. It's the wind tight layer is probably the second most important layer in our building, and it's really not given a great deal of consideration. People tend to cover houses in the, let's say, the typically available builder's merchant products. So that is the cheapest product that you can buy. But what do we want from our wind tight layer? We want it to be watertight for sure, but on a windy day, certainly in Ireland, we can have huge impacts through the cooling of insulation from wind. So it's the equivalent of standing outside on a windy day in a woolly jumper. If you can add something to prevent the wind, your woolly jumper gives you something. It's the same principle. If we've got a sloped roof, it makes sense to tape all the joints, prevent that wind passing through. It actually kind of has the same type of impact that we spoke about on U values. So that cooling effect of the wind passing through insulation on a worst case basis can make a difference of about 1/3 on your actual performing U value. On the products themselves, we probably about 90% of the market uses microporous right now. Microporous products are a 3-layer product. They were an innovation when they were, I guess, first launched about 20 years ago, but they are made breathable through a calcium carbonate, which is added during the production process, and that creates small holes in the material. That's how it's breathable, but that has disadvantages. Those small holes can become blocked, and in addition, if we use the lower cost products, it tends to mean that the non-woven protective layer on top and bottom is not UV stabilized, might not be strong enough. Monolithic technology is the next generation. It's what we use. We use a solid breathable layer in the middle. So it means that the water vapor passes through it in a molecular way, not through small holes. So far less susceptible to damage over time or getting blocked. And ultimately it means that the better quality products, while they may look the same or may not be stronger, will have a lifespan about 15 times longer than the microporous products. We've got 2 main products in this range. That is the Exoperm Mono 150. It's our main exterior product, a really long life, high quality product. There is also a newer version now available. This is a 2-layer technology where we use the monolithic layer on the outside. And Exoperm Mono Duro has additional characteristics. It has UV stability, so it can be used in open joint facades for warranted for 10 years, but it also has a class B1 fire behavior. So it's a really interesting type of product. It costs a little bit more, but I guess from a long-term carbon point of view, it can really help to extend the life of the building. So yeah, small enough figures really in terms of what you get for it. So we've looked at the membranes, the building physics. It's time to look at kind of what joins it all together. So the types of adhesives that we use and that people choose are very, very important. So what we're actually talking about is using a solid acrylic adhesive that is can give us a moisture resistant system and real long-term adhesion. From Partel, you'll see products with nice, clear, kind of easy to understand names. The VARA range we've talked about already. In addition to that smart function, it can actually be plastered over and can be used internally and externally. Connexo, you'll kind of guess from the name, is designed to connect exoperm, so connect exoperm. It's a multi-purpose tape, can be used internally or externally. Kineso is primarily an interior tape and is designed to connect isoperm. We won't go into it in full detail today, but there is a huge range of system components available. So from the permanently flexible liquid adhesives to flexible flashing tapes. This is an image of the cab seal grommet that we saw sealing pipes earlier in the presentation. But we're also quite fond of the pre-compressed tape, so Conpreseal. This one in particular actually has built-in air and wind tightness, so can actually remove the need for a window sealing tape on the inside and the outside. They also help to achieve final install quality. So rather than kind of having a high performance window with, really good sound insulation and failing to get something like this or using spray foam, this can complete the window install. On the tapes and the adhesives itself, we use the highest quality adhesive available, but there is some interesting things to know about that. The adhesive itself takes 24 hours to reach its full strength, and you need to activate that adhesive. So it needs pressure, it needs to be applied and pushed into place. But probably the most interesting thing for us is the long-term balance. So we're striving to have an appropriate amount of cohesive, peel, and tack adhesion on our tapes. And the end result of that is that we get products that can last a lifetime, and we're sure that they can outlast the components that they're attached to. You will see some products that perform really well in a tack test, but it's a very poor way to judge the long-term stability of a tape. When we're applying tapes, we need to be sure and make sure people are checking to see that the surface is clean and dry, so the adhesive sticks just as well to dust as it does to anything else. If in doubt, we should be using primers on all porous surfaces. So it's just a logical kind of thing to do. If we do that, it's a small amount of labor, a small cost, but you're sure of the application. If you don't do it, you're really taking a risk. And yeah, generally we're looking at avoiding folds, creases, and that applies for membranes and tapes. Onto the testing. Look, for us, this is, I guess, fun and interesting, and it's a validation of what we do, but it also gives us, real certainty long-term over how the products will work. But looking at the adhesives, we are tested to the only standard that there kind of is available for airtightness tapes, and it's worthwhile knowing that there is no CE standard for airtight tapes at present. So you do need to be careful that you choose an appropriate system that's tested as a system. So because there's no standard, it does mean kind of anyone can label anything as an airtight tape. Because of the internal testing we can do, we can test new substrates if you have something you want to do an adhesion check on or anything like that. But it does mean we perform our own QA on tapes and yeah, can develop quite a good knowledge of how tapes perform in different conditions. So looking at the best location for an overall system test, a DOP for a membrane will give you certainty that the membrane is produced and tested to a good level, but it doesn't deal with the combination of tapes, adhesives, overall as a system and in different ways. So we have went to the Passive House Institute, we've had our full system test, and we've got some pretty amazing results. It's one of the lowest or the best scores in the world. You can see it actually under test in the Passive House Institute here. So they test on membrane to membrane, membrane to OSB, and membrane to concrete. End result is essentially a zero figure. It's a negligible air leakage, and it should give you that certainty that the system overall is performing to a really high level. On thermal bridging solutions, it's kind of a new area, I guess, for a lot of people, but maybe it shouldn't be. We are in every BER or assessment of a building, there is a section where we're choosing that we're building to accepted construction details or to ACDs. That probably isn't always the case, and we are starting to see it develop as a standard, and people are starting to check to see what the actual factor of safety is and compliance is with building regs. In commercial buildings, that's already the case since 2018. It's pretty much all details been tested, but there's huge benefits to that. If you do have let's say like a lot of the offsite production the timber frame guys are doing, they're starting to produce their own suite of tested details, and it can make a pretty big difference on your final BER. So it'll show the actual performance of your thermal bridging rather than taking a standard, and that can reduce the amount of PV or your final costs. So it's worthwhile investing in thermal bridging. One of the products that we offer is Alma Vert. It's a completely recycled core material. It's used underneath windows and doors primarily. You can see some thermal modeling with the product used as part of the Alma T threshold here. But really what we're doing is we're able to keep that kind of higher risk area temperature at an appropriate level. The failure to use something in this location could mean kind of a cold spot, the equivalent of a draft at that location. So this is the product Alma T. It's been used with social housing in Dunleary at Down. It's a Part M accessible integrated, so we build in the drainage, but it's working quite well and is a really uncomplicated way to deal with that junction. If you don't need Part M accessible, you can use smaller parts and just use that section. We also offer compact foam. Compact foam is a really, really interesting product. It has some different applications to Almavert in that it is really suitable for mass production or large volume. So if we're using something like a cladding system and we want to use small brackets, compact foam is excellent for that. But generally, both products can be treated as a softwood timber on site and machined to shape, whatever you need on that. We'll take a look at some of the projects or the recent projects we've been involved in. This is very recently completed. It's the Limerick Hospital extension where they chose to use Exoper Mono Duro for two reasons, for fire and durability. This is an example of what is Ireland's most expensive penthouse apartment, and a little bit of an interesting story in that the shell was built, I think, in 2016 or 17, where there was at that time, a different plan for the level of insulation required. So they had already some insulation on the outside, and we had to come up with a functioning system that wouldn't create any issues for the flat roof. And because they were using a combination of metal and timber, we did have to look a little bit closer to provide these little solutions that could maintain the airtightness in the apartments. This is a nice example of a self-build low energy house. So no reason why it can't apply to this type of project, the same level of detail. It's just good planning. And yeah, you can see nice thorough application, even with these kind of issues through floors, right up into the ceiling. But in the end, a completely consistent and thorough airtightness layer throughout. Little things like that are things that might be highlighted in a blower door test. So it's definitely okay for there to be cuts in the membranes, but we just need to find them with the blower door test. This is an example of a certified passive house in Cheshire in the UK. Same kind of principle in that we were using the full system. So everything from the Exoper Mono through to the Isoperm Plus on the inside. So yeah, below 0.6 in that. And we're also a pretty key supplier to the offsite industry. This is Graven Hill in the UK, where again, we're supplying full system components. So from the outside to the inside, and people are routinely getting below 0.6 in the airtightness there. This is I guess nice to see a winter project, but it's what they call an energy efficient standard in Vermont. Interestingly, in this one, they kind of built from the outside. So the app is still VARA plus membrane, but finished, using the Exoper Mono, but built to the outside. So because it was a retrofit, they could maintain some things internally. These projects in New York, where we supply, again, kind of a full system of products, are a real challenge. So typically they're dealing with very old brick with real complications in how to make it airtight. So we found that the fluid applied, VARA Fluid, can be a big change in speed and efficiency on site. We still take the VARA Plus layer through the floors and connect it at ceiling level. And you can see here the VARA Seal X tape being used to, I suppose, to pre-prepare the windows before it's inserted into the openings. So overall, kind of what you're getting from Partel to help with nZEB, it's full systems and product warranties. We still carry design indemnity, a lot of external testing from BBA to Fraunhofer, Passive House Institute. The same kind of really with the product testing internally, and we're absolutely open for technical advice, WUFI analysis, U-value measurements, that kind of thing. So overall, I'm kind of going to stop the presentation, switch back to Andrew, and we will try to get into some Q&A. I'm going to try switch back to you, Andrew.
Thanks, Hugh. Much appreciated.
Okay.
Excellent. Yeah, I'm back again here, so that's good. Thanks for the presentation. Very good information. I think everyone will agree there on that one. A lot covered, and it's great doing these things because it's nice to learn a bit from my point of view as well.
Yeah, it works both ways, I think, Andrew.
It works both ways. Yeah, absolutely. So yeah, there are a few questions have come in here. All right, I'll just grab these together for you. Just, I suppose, a few simple ones. First off, just in terms of the WUFI analysis and you assisting on projects and that kind of thing, is there a charge for that, or how does it work in with the different projects?
Yeah, I guess it's something I was working on today for a project in Cork, but we don't charge if we're using our own products. So we really try to support the knowledge or the knowledge gain that the architect or specifier will get from going through that process. But yeah, I might regret it sometimes, Andrew, because it's quite a time-consuming piece of software to use. But
sure.
Really, we enjoy that one. So yeah, there's no charge in that.
Excellent. That's great to hear. That's great when people support the people in the industry. That's really good. Just in terms of liquid applications and that kind of thing, can that be used along with EWI, external insulation?
Yeah, we've done projects with that where you can kind of fully apply the product to the outside, and it's definitely a smart way to approach the airtightness. And yeah, you can still get certified passive house results from doing that. So the fixings from the EWI will actually pull through the VARA fluid and maintain the level of airtightness.
Okay, well, that's a good one to hear, because that it's good information I can share with people in our industry as well, which is nice.
Yeah.
You just mentioned there the tapes, there's a lot of stuff out there, and there isn't necessarily a CE mark just yet on that. So if somebody is out in the industry and they're looking at all the different types, how do they differentiate what's good and what's bad?
Yeah, I'd kind of really cycle everyone back to the Passive House Institute. It's the only independent test of a full system. So, I guess if I'm honest, there's a lot of marketing out there and a lot of people selling and kind of pushing different things. And for sure, there's good products out there from lots of different suppliers, but that's a really good way to assess and compare the different products on the market.
Okay, very good. Is there a heat resistant grommet for sealing around twin wall flues when we're dealing with air tightness?
Yeah, it's a good question. So the cab seal grommets can go up to 120 degrees. So you do need to get some feedback from your stove provider as to what the temperatures are likely to be in the twin wall at that point. But most twin wall systems should be kind of well below that temperature at the point where they pass through the airtightness layer.
Okay. Question here regarding some steel frame construction, and as we all know, it's getting very popular. In terms of, I suppose, dealing with airtightness membranes and Windtightness, how would be best to fix the membranes to steel frame?
Okay, a lot of the steel frame companies are using or having to use fiber cement boards to deal with the fire rating. So it tends to mean that board is fixed to the membrane or to the steel frame on the outside, and that's also a good location to integrate your airtightness. So you can staple the airtight membrane to the cement board, and after that it kind of becomes, I guess the trick after that is how do you connect the walls with the ceiling. And it depends on the company, but most guys are getting to that point where they're working out a full system, and it's something we'd consult on quite a bit.
Okay, thank you. The VARA Fluid clear, if you're painting onto an existing wall, is it clear, or is there a color to it, or how does that look?
Yeah, it's a beige in color. We do have it in a black that dries from blue to black as well, and there is kind of on demand a white version, but you can paint over it, and that's probably the best approach if you want to have something different.
Okay, and what was the name of the heat resistant grommet again?
It's cab seal.
Cab seal. Okay,
yeah, it's on our website.
Yeah. Let me see. Just a question regarding not necessarily maybe your field, but anyway, spray foam and air tightness, is there kind of pros and cons, or are you better sticking to the membranes?
Most spray foam installs require a membrane anyway.
Okay.
So probably the guy selling you that might know that or might not always say that.
Sure.
But if you do your due diligence, you will see that I think there's one out there that says it may not be required if
Yeah.
there is a WUFI condensation risk assessment, and only if you receive a bespoke WUFI condensation risk assessment should you consider not applying an airtight membrane.
Okay, and just kind of on the exterior membranes, again, we're looking at the market, and there's various ones out there. Are they specified by weight or strength, or what are the key things you need to be looking at there?
Yeah, we do find that people tend to choose those products based on strength, which is look, that deals with the construction side of it. I guess that people don't damage it, or it helps with that, but it has no relevance to the longevity of the product. So you do need to be careful, really not to judge on strength. It's not the way to assess the long-term performance. So look for the monolithic technology, look for the UV stabilized and products. But yeah, a big thing with that is when you see products say cover as soon as possible, that's an indication that it will degrade if it's exposed to the sun.
Yeah, okay. Just a question there about the presentations. They will be shared later on. Hollow cavity block built house. I suppose older construction. What's the best way to achieve maybe some airtightness on the external walls? Would it be external or internally? What would be the best kind of approach to that?
Probably for one like that, external wall insulation would be the best option. So that's something that can deal with all of the thermal bridging kind of in one go. So you can introduce your airtightness from the outside and then build on the insulation to the outside. If you have to do it from the inside, it's something you would assess in WUFI, but those types of blocks aren't always amazing at keeping the driving rain out. So it does mean that you can have an impact on the internal insulation from rain, and that's really hard to deal with. So you need to be sure it's sealed from the outside, and then you can use the VARA system on the inside.
Okay, thank you. And just a general kind of question here. Is nZEB already adopted in building regs? And if not, do you see it as part of a Build Back Better and Green New Deal?
That's a UK question, I guess.
Okay.
nZEB, the UK just had it's not formalized, the release in Partel, so it's coming pretty soon. There's slight differences, but most standards, I would say Ireland is a little bit ahead right now.
Yes, yeah.
But it is moving to that kind of direction, but definitely not there yet. That said, there's some really, really interesting and high quality, low energy projects going on in the UK. So it can be a choice by the installer as well.
Sure. Just on fixings for service battens, would they self-seal to the airtight membrane, or how do they kind of interact with each other? Is there anything that we suppose need to be careful there?
Yeah, it's a good question. So kind of because of how the isoperm and VARA plus membranes are produced, they all have that kind of a polymer in them. So when we screw the battens in, that will create heat and draw the membrane into the timber, pulling it tight, and you never have leakage at that location.
Very good, very good. You were mentioning there about staples. Who I suppose whose responsibility would be to specify these? Just a question there, kind of if the site is close to a marine environment, could that be an issue as well?
On the exterior, I guess, in this location. Yeah, I mean, we do specify the staples that should be used, so you'll see it in the install guides for all the membranes. But in terms of marine environment, you will always have, or should have, a rain screen to the outside that is, really dealing with the wind. So should just be a vented cavity. So I would say things are standard.
Okay, thank you. Are there different recommendations for permeability of materials for different weather zones? For example, the wind-driven rain exposure west of Ireland.
Yeah, it's a great question, and I guess a big topic. So I guess we have unique conditions where we are in Partel. We have almost the highest rainfall in the world, coupled with the Atlantic. So it definitely gives a nice place to test products for wind-driven rain. So generally, if there's a problem, you'll find out. But going back to that, I mean, that rainfall, really it just means that it's okay to use better products, and you should be okay with that. So more thorough external sealing, choosing the Duro product above, a cheaper product, just makes sense in that kind of a weather condition.
Yeah, absolutely. In relation to timber frame build, can the air tightness layer be moved from the inside to the outside or cavity side? And if so, can a Windtight or airtight product be applied here and used to achieve your air tightness?
Okay. There is one kind of situation where that can work. You need to assess it in WUFI. So you can use one of our outside products to achieve the air tightness. All of our exterior membranes are also airtight. So they can do that job, but what we really need to be careful about is the breathability and how the moisture is moving through that construction. But it's definitely not something you can just change. There is a difference in how it's built. You need to have your timber frame with insulation, then your air and Windtight membrane, and at least an additional 50 millimeters of further insulation outside that. And it's definitely site specific. So it can work. The application needs to be perfect, and you need to do that bespoke analysis.
Okay. Just airtight options on existing. So again, I'm sure there's thousands of people out there with existing houses, and it's a block house, windows and doors. Do we need to go at the reveals of the doors? Is there tapes, adhesives that can be used to I suppose negate big work?
Yeah, I mean, you can always make improvements. You could take a product like VARBOND. It's a polymer adhesive that we have that can gap fill. So if you kind of don't want to go down or can't go down that route for whatever reason, that's a really good and flexible product to gap seal. And yeah, outside of that, really, you are looking at making kind of bigger changes.
Yeah, getting at those reveals, really. Yeah. How do you recommend for sealing for air tightness around multiple cables coming through walls and ceilings, I suppose, penetrations like that?
Yeah, so there's planning for it and giving them kind of space is the big thing. So we need to kind of not group them all as one section, but probably a bigger impact is to keep all of those, or the majority of those cables, inside the airtight layer. And that really deals with the volume of it. So that's kind of why you'll always see a batten inside the airtight layer, where people will provide a service cavity, and that makes the biggest difference. But outside of that, it's really about giving enough room around each pipe or cable to allow sealing around it.
Okay, great. Yeah, I think I've covered most of the questions there. Hold on, possibly one more. Hang on one sec.
Yeah.
If you're using the Alma Vert under a door threshold, can you render onto the external side?
Yes, that's an easy kind of simple answer. So you can pretty much substitute Alma Vert or compact foam, with the standard EPS or from you guys. So it's interchangeable. I see another question in the general chat there about removing of internal plaster before using VARA Fluid. You definitely don't need to do that. All you really need to do before applying the spray applied products is to remove anything that's loose. So if the plaster is well adhered, we can spray over it.
Okay, excellent. Yeah, I think that's pretty much them all. Thanks, Hugh. That was really interesting. As I said, it's great because it's nice to learn things myself as well.
Still awake, Andrew, anyway. So you're the only one I can see. So
I had the water. It kept me going. I was fine. So no, I think a big thank you to you for that. That was really good. As I said, it's nice to get other people's views on things. We get kind of caught up in the bubble of what we do from day to day. So it's really good to hear from other people in the industry, and hopefully people who I suppose attended got a little bit out of it. Oh, hold on. One more question just before you go, Hugh. Can a warm deck flat roof be constructed as a cold deck using Partel products?
Can a warm deck flat roof be constructed as a cold deck? can assure you exactly what they mean in that instance.
Yeah, I mean, changing from a warm roof construction to a cold roof construction would mean changing a lot of other things. It wouldn't be just, I suppose, the brains end of it.
Yeah, our products are used a lot in flat roof construction, and it's probably the area that it's probably the area that still carries the biggest risk. So I think people are, I don't know, maybe overconfident with flat roofs right now, because there's some really great products for weather sealing them from the outside. So the layering underneath that is really, really critical. If we choose, let's say, for example, a very light product on the outside, and we've underneath that got OSB or plywood, you would think that that's okay. Sorry, I should say full fill insulation, but it can fail depending on the site, because it is reducing the amount of sun getting into that roof. So it's best to check those flat roofs, and if whoever's got that question wants to engage after this, we can get into the detail on it.
Okay, and then there was just one more little one there in the chat there. Thoughts on approach to insulator provide air tightness on a solid wall built building with architecturally protected external faces.
Yeah, that is actually the exact thing I was working on this morning, and will be for the next day and a half. So it's not, it's probably the second most high risk. So if we can't be sure it's sealed from the outside perfectly from driving rain, we need to build the impact of that into the WUFI assessment. And only then can we kind of see if it can deal with it or not. But it's definitely not a certainty. You need to check that. So again, happy to engage in that.
Okay, another little one here. In the liquid flash product seems to be something available over in the States. Have you heard of it, or do you do anything similar?
Yeah, that product is in the States, so it's available to buy, and it's in use out there already. Sorry, I should say liquid flash. That is I'm assuming for Owen, that is the brush applied version of the VARA Fluid. Okay. It's a product you can use on the outside. It's not as vapor open, but it's perfect for flashing like that, and has really good UV stability if it isn't covered quickly. Okay,
and just a question there, contacted for assess for what system to use. I suppose just reach out to yourselves, get in touch, give kind of as much detail as they can, and you can advise them then accordingly.
Yeah, exactly. Yeah, I mean, a section of what you're kind of worried about or thinking about is the best way to go.
I suppose a very open question here. How do you seal outlets?
Cab seal or conlex. I'm assuming that's ducts or pipes, penetrations, that kind of thing. So I would guess that's what it is.
Okay. Well, I think we've covered everything. As I said, thank you very much again. That was really good. Just a reminder to people, I suppose, who are on about the upcoming sessions that we have as well. So we've different topics and learning objectives coming up with different sessions. As you can see it here, it's on the screen. So thank you to everyone that's come along. All the CPD sessions, as we go through them, they will be recorded and made available afterwards as well. So next week, we have me, unfortunately for people, or fortunately, whatever way you look at it, and followed by Daikin. Following week, then we have some looking at timber frame construction, windows, Nordan, Harmony timber frame. And then the final week, we'll be looking at some ventilation solutions for energy efficiencies. And then a final plenary session, which is going to be handled by Jeff Colley from Passive House Plus magazine. So we've a lot to get through over the coming weeks, but hopefully people can come along and join us and get what you can from it. So just a final thank you, and thanks everybody for coming along. See you all soon. Bye-bye.
Thanks all. Bye.
Bye-bye.